Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at synthetic division. So synthetic division is an alternative to polynomial division. For when we have polynomials like this that we can't factorize easily, there's no highest common factor, we can't group the terms, etc. So we're going to do the exact same thing as we would with polynomial division. So to solve this equation here, I need to come up with a root first. So if I call this polynomial f of x, there is an obvious root here, and that's 1 because the coefficients add to 0. So we have f of 1 equals 0. 1 is one of the solutions to this equation. We will use synthetic division to find the others. So for synthetic division, you use the root. We write it here, that's 1. And what we do is we write the coefficients of the original polynomial. So they are 1x cubed, 1x squared, negative 10x, and 8. So people often find synthetic division much easier because you don't have to write all the x's. So what we do is we first bring down this first term 1. Now whenever we get something down here, we multiply it by the root. So I go 1 times 1, obviously 1, and we stick that up here. Now, when we're calculating remainders in synthetic division, we add rather than subtracting. So that's another aspect that tends to make synthetic division easier. So 1 plus 1 is 2. When we get a number down here, we multiply by the root. So now we go 1 times 2, which is 2. I put that up here. Again, we add. So we have negative 10 plus 2, that gives us negative 8. And once again, when we get something down here, it gets multiplied by the root. So we go 1 times negative 8 is obviously negative 8, and we put that up here. And once again, we add to find the remainder. 8 plus negative 8 is 0. So what exactly do these numbers mean? Well, we know that we are essentially dividing this polynomial by the linear factor x minus 1. Even though we didn't write this, we are doing exactly the same thing as when we use polynomial division. So we know that when we divide a cubic by a linear polynomial, the answer is a quadratic. So these three numbers here are the coefficients of that quadratic. So this divided by this is equal to, first coefficient 1 is of x squared, 2 is the coefficient of x, and negative 8 is the constant term. So this last number here, you might be able to tell that is the remainder of the whole division. And it should be 0 because we know that x minus 1 is a factor. So what have we found? We found that fx, which was this original cubic polynomial, can be written as x minus 1 multiplied by this quadratic that we just calculated, x squared minus 2x minus 8. So just as we would do when using polynomial division, we reduce the cubic to a quadratic that needs factorizing, and quadratics are much easier to factorize. Two numbers that multiply to negative 8 and add to 2, they are of course positive 4 and negative 2. So of course, to solve this equation up here, we now use the null factor law. Either the first factor is equal to 0, the second factor is equal to 0, or the third factor is equal to 0. All right, let's now look at a slightly harder version. So we're going to solve this quadratic here with the aid of synthetic division. Once again, we need to come up with a root first. So I'm going to try negative 2 since it's a factor of this here. So if I substitute x for negative 2, it turns out I get 0. So I'm going to use that in my synthetic division. I write the root here, and then I write the coefficients of the original polynomial 4, 12, 9, and 2. So we always start by bringing down this number 4. Multiplying negative 2 by 4 gives us negative 8, so I'll put that there. We add to find the remainder. Now we go negative 2 times 4, that gives us negative 8. 9 plus negative 8 gives us positive 1. And then, of course, negative 2 times 1 is negative 2, adding to get the final remainder of 0, which is what we expected because we know that x plus 2 is a factor. So we have just found that f of x is equal to x plus 2. We already knew that was a factor, but these numbers here are coefficients of the resulting quadratic. So it's 4x squared plus 4x plus 1. So we can factorize this quadratic using the usual methods. We might choose AC methods. It turns out to be 2x plus 1 all squared. So the solutions are x equals negative 2. That makes the first bracket equal 0. And the number that makes the second factor equal 0 is negative 1/2. But how do we use synthetic division if it didn't have an integer root? Let's now take a look at that.